Yeah. So in this triangle, we have triangle, we have four quadrilaterals. DB, DBEF, DECF, and ADEF. These are the four quadrilaterals. You need to prove that each one of these four quadrilaterals are parallelograms. You need to prove that each one of these quadrilaterals are parallelograms. And to prove that, you have to use the property that in a quadrilateral, when one pair of opposite sides are parallel and equal, the quadrilateral is a parallelogram. In a quadrilateral, if one pair of opposite sides are parallel and equal, then the quadrilateral is a parallelogram. That's what you're going to use to prove that these four quadrilaterals are parallelograms. And for that, we have to use the midpoint theorem. We'll have to use the midpoint theorem. All right? Okay. And so first you have to use the midpoint theorem, show that these four quadrilaterals are parallelograms. Then once you prove that DBEF is a parallelogram, the property of the diagonal in a parallelogram, the diagonal divides the parallelogram into two congruent triangles. You don't have to prove that because then it will become very lengthy, the proof. So you don't have to prove that. You can take that result because as it is, the proof is lengthy. So you can just state the property in a parallelogram. The diagonal divides it into two congruent triangles. So once you prove that this is a parallelogram, the diagonal DE divides it into two congruent triangles. So triangle 1 is congruent to 2. In the same way, now that you've proved this is a parallelogram, the diagonal FE divides the parallelogram into two congruent triangles. So we already have one congruent to 2, one congruent to 2. Now you will have one congruent to 3, one congruent to 3. And then you would have proved that this is also a parallelogram. So the diagonal DF, the diagonal DF. Okay. The diagonal DF divides this parallelogram into two congruent triangles. So one is congruent to 4. One is congruent to 4. So like this, one is congruent to each of the other triangles. So that means all the four triangles are congruent to one another. And that's what we have to prove here. Show that triangle ABC is divided into four congruent triangles by joining D, E, and F. All right. So take up the triangle ABC. In triangle ABC, D is the midpoint of AB, F is the midpoint of AC. Therefore, by midpoint theorem, DF is parallel to BC and DF is equal to half of BC. All right. So DF is parallel to BC and DF is equal to half BC. So now take up the quadrilateral, which you want to prove is a parallelogram. Now take up the any one, you can start with any one, but since we've got these results, we'll take up this quadrilateral and show that this one is a parallelogram. So in this quadrilateral, okay, we've proved that DF is parallel to BC. That means DF is parallel to BE. Correct? We proved that DF is parallel to BC. That means DF is parallel to BE. And DF is equal to half BC. And what is half of BC? BE. So DF is equal to BE. So DF is parallel to BE and DF is equal to BE. See, DF is parallel to BE because DF is parallel to BC. And DF is half BC. What is half of BC? Half of BC can be replaced with BE or EC. So you take BE here. So in this quadrilateral, one pair of opposite sides parallel and equal. Therefore, it's a parallelogram. And the diagonal divides it into two congruent triangles. And hence, this triangle is congruent to this triangle. Now, you can use the same results for this quadrilateral. since DF is parallel to BC, it also means DF is parallel to EC. Because DF is parallel to BC, it also means DF is parallel to EC. And since DF is equal to half BC, it also means half BC is what? EC. Now we take EC. So this can be replaced with EC. So DF is equal to EC. DF is equal to EC. So one pair of opposite sides parallel and equal. So this is a parallelogram. Okay, so that's what is still here. And the diagonal divides it into two congruent triangles. And hence this triangle is congruent to this triangle. Now to prove that this quadrilateral is a parallelogram, because we are done with this information. No, see, we have made full use of this information. Nothing remains now. Now, if you try to use this again, you will get one of these two results, which we've already got here. We've used this fully, completely. So you need to use the midpoint theorem again. Okay, so again in triangle ABCC, we have taken D and F are the midpoints and we got these two results. Now take D and E are the midpoints, or you can take E and F are the midpoints, any one. Here we have taken D and F are the midpoints. What remains after D and F? You can take D and E are the midpoints, or E and F are the midpoints. So take any one of the other two remaining and use the midpoint theorem. So what have I done here? I've taken E and F. I told you it's not that you should do only with E and F. You can also do with D and E. Okay. So E is the midpoint of BC, F is the midpoint of AC. So which means this one is parallel to AB. EF is parallel to AB, and EF is equal to half of AB. Correct? Yes. So EF is equal to half AB means EF is equal to AD. And parallel also we got. So one pair of opposite sides parallel and equal. Therefore, this one is a parallelogram. This one is a parallelogram. Because by midpoint theorem, we have this parallel to this and this equal to this. If you use D and E as the midpoints, D and E as the midpoints, you will get this one is parallel to this one. And this is parallel to this one, and this one is equal to this one. You will get the other pair of opposite sides parallel and equal. So you can use use D and E or E and F, whatever. So now again say DF is a diagonal and it divides it into two congruent triangles, and hence this triangle is congruent to this triangle. Now comparing all the four, you can also number them 1, 2, 3, 4. Presentation, see, all this is important. Presenting the midpoint theorem correctly and mentioning the points to show that they are parallelograms, all that is very important. So this is about the first one. All right. The others will be pretty faster because so here you all remember the midpoint theorem and converse of midpoint theorem, right? Midpoint theorem, two midpoints should be given. Midpoint theorem, two midpoints should be given. The result will be one side is parallel to the other side and that side is equal to half of the other side. Converse of midpoint theorem is you're given, converse of midpoint theorem is in a triangle, if say this is the midpoint in triangle ABC, if D is the midpoint of AB and if DE is parallel to BC, if DE is parallel to BC, then the result by converse of midpoint theorem is that E is the midpoint of AC. Yes. E is the midpoint of AC. Midpoint theorem is D is the midpoint of AB given, E is the midpoint of AC given. By midpoint theorem, DE is parallel to BC, DE is equal to half BC. Converse of midpoint theorem is only D is the midpoint of AB and DE is parallel to BC given. Result, E is the midpoint of AC. That's all. Only one result. E is the midpoint of AC. Only one result for converse of midpoint theorem. So here, you just have to connect AF. And in triangle ACF, I'm not allowing you to read the question. If you have your textbook with you by any chance, math textbook. How many of you got it? No, say yes or no. No, that's what I want. Yeah. Fine. Okay. LMN are parallel lines and LMN are parallel lines. P and Q are the transversals. AB is equal to BC. AB and BC are the intercepts on the transversal P. AB, this piece, and this piece, AB and BC, those two pieces are the intercepts. Intercepts on the transversal P. And they're equal, is given. They're equal. The intercepts AB and BC are equal. You need to prove that the intercepts DE and EF are also equal. You need to prove that the intercepts DE and EF on Q, on the transversal Q, are also equal. L, M, and N are parallel lines intersected by two transversals P and Q. AB and BC are the intercepts on the transversal P. Those intercepts are equal is given. We need to prove that the intercepts DE and EF on the transversal Q are also equal. Very simple. Just connect because we don't see triangles. So connect this. Now we see two triangles. Because it's given AB is equal to BC. AB is equal to BC is given, right? So that means B is the midpoint of AC. So B is the midpoint of AC. And these three are parallel lines. So just mark this point G. And BG is parallel to CF because all the three lines are parallel. So BG is parallel to CF. So by converse of midpoint theorem, G is the midpoint of AF. Okay, in triangle ACF, B is the midpoint of AC because AB is equal to BC. And M is parallel to N. M is parallel to N. If M is parallel to N, BG is a part of M and CF is a part of N. Yeah, so M parallel to N, so BG parallel to CF. So by converse of midpoint theorem, G is the midpoint of AF. Now take the other triangle AFD. In triangle AFD, we just proved that G is the midpoint of AF and GE is parallel to AD. Why is GE parallel to AD? Because M is parallel to L. M is parallel to L. So any part of M will be parallel to any part of L. A small part can be parallel to a bigger line segment because when for lines to be parallel, they need not have the same, for line segments to be parallel, they need not have the same length. If two line segments are parallel or have to be parallel, they need not have the same length. We are not saying that they're congruent. Congruency means equality. This is parallel. So a small line segment can be parallel to a big one like this. Okay. So G is the midpoint of AF. G is parallel to AD. Therefore, by converse of midpoint theorem, E is the midpoint of DF. So if E is the midpoint of DF, it means DE is equal to EF, which means show that L, M, and N cut off equal intercepts DE and EF on Q also. Show that L, M, and N, the parallel lines L, M, and N, cut off equal intercepts DE and EF on Q also. All right. Remember this. So when you have a quadrilateral, quadrilateral with midpoints of all the sides, when you have a quadrilateral with midpoints of all the sides, and you connect them. So we have a quadrilateral inside another quadrilateral, right? We have a quadrilateral inside another quadrilateral. Okay, now, if the outer quadrilateral, given such an information, if the outer one is a quadrilateral, if the outer polygon is a quadrilateral, then the inner one is a parallelogram. If the outer one is a parallelogram, the inner one is also a parallelogram. If the outer one is a rhombus, the inner one is a rectangle. If the outer one is a rectangle, the inner one is a rhombus, square, isosceles trapezium, rhombus, kite, rectangle. 1 mark. We have two quadrilaterals, right? One outside and one inside. Inside one is formed by joining the midpoints of the sides of the outer one. The inside rectangle is formed by joining the midpoints of the sides of the outer one. So if the outer one is a quadrilateral, meaning it's just a four-sided polygon, then the inner one formed by joining the midpoints is a parallelogram. If the outer one is a parallelogram, inner one is also a parallelogram. If the outer one is a rhombus, inner one is a rectangle. If the outer one is a rectangle, the inner one is a rhombus. Square, square. Okay, isosceles trapezium, rhombus, then kite, rectangle. You can kite rectangle is easy because kite and rhombus are quite similar, no? Kite is kite. This is a kite. This is a kite. Rhombus. You have to remember, no, you need something to remember. So like kite and rhombus are, they're not identical. They're two different quadrilaterals. They have different properties, but kite has a few properties of a rhombus. Okay. So rhombus is a rectangle. So kite also is a rectangle. So kite rectangle. And then isosceles trapezium rhombus. Isosceles trapezium rhombus. Maybe useful for 1 mark. These are very direct ones. You have to connect one of the diagonals of the outer quadrilateral. You'll have to connect one of the diagonals of the outer quadrilateral. Then use the midpoint theorem in this triangle. That is, S is the midpoint of AD, R is the midpoint of DC. Therefore, SR is parallel to AC and SR is equal to half of AC. No, you prove whatever is asked here. I'm just telling you the end result, how to prove this one. Then in the other triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. So by midpoint theorem, PQ is parallel to AC and PQ is equal to half of AC. Now by comparing these results, you will get SR is parallel to PQ and SR is equal to PQ. Therefore, PQR is the parallelogram. What I mean is, see, this is from triangle ACD. From triangle ACD, we get these two results. From triangle ABC, we get these two results. Now see here, SR is parallel to AC. PQ is also parallel to AC. That means SR is parallel to PQ. SR is parallel to PQ. SR is equal to half AC. PQ is also half AC. So SR is equal to half AC. PQ is also half AC. That means SR is equal to PQ. SR is equal to PQ. And in this quadrilateral, one pair of opposite sides parallel and equal. So PQR is the parallelogram. It's a pretty lengthy one. We'll just postpone it to the next class because if I do this, then we might have to spend a lot of time on this, which is equivalent to 3 proofs. So it's not difficult, it's lengthy. So I'm ignoring the second one. So here, ABCD is a rectangle. ABCD is a rectangle. Mark the midpoints carefully. See, P is the midpoint of AB. Oh, yeah. Where is it? P is the midpoint of AB here. So P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of DA in order like that. Now join. You need to prove that this one is a rectangle. The inner one is a rectangle. The inner one is a rectangle. What's the definition of a rectangle? A parallelogram in which one angle is a right angle. No, a parallelogram in which one angle is a right angle is a rectangle. Yeah. So a parallelogram in which one angle is a right angle is a rectangle. So you need to prove that PQRS is the parallelogram. Parallelogram. Everything starts from the parallelogram. Okay. So everything starts from the parallelogram. So how do you prove it's a parallelogram? Join one of the diagonals of the outer quadrilateral. Don't see if you do this, if you connect the diagonal of the inner quadrilateral like this, then you don't have midpoints at all. See, you're like, you, by doing this, you have created triangles which, where the information regarding the midpoints cannot be used. Connect one of the diagonals of the outer quadrilateral. So you can do this or BD. Then prove same thing like what we did the earlier proof. Prove that this one is a parallelogram. Now it's a parallelogram. One more step. Now what is this? Prove that it's a, okay. The outer one is a rectangle, inner one rhombus. Okay. So the outer one, the outer one is a rectangle, the inner one is a rhombus. Sorry. So what's the definition of rhombus? What is the definition of a rhombus? I asked you for a rectangle. Here the given quadrilateral is a rectangle. We need to prove it's a rhombus. The inner one is a rhombus. What's the definition of a rhombus? A parallelogram in which adjacent sides are equal. You need to அந்த இது சொல்லக்கூடாது, definition, not all the properties. Definition. What's the definition of rhombus? It's a parallelogram. It's okay. You'll have to prove the quadrilateral is a parallelogram. And after that, in the parallelogram, you need to prove any one pair of adjacent sides are equal. Any one pair of adjacent sides are equal. First prove it's a parallelogram, then any one pair of adjacent sides equal. Therefore, it's a rhombus. Yeah. So parallelogram is very simple because we'll have to take this triangle ASC and this triangle ABC, correct? Midpoint theorem. Then after that, you need to take up these two triangles. This triangle. Now you prove that PQRS is a parallelogram. Now you need to take up this triangle and this triangle. Any two adjacent triangles. See, I'll mark the four triangles. See, I'll mark the four triangles. So here you can take up 1 and 2, triangle 1 and 2, or 2 and 3, or 3 and 4, or 4 and 1. Don't take 1 and 3. Don't take the opposite triangles. You can take any one pair of adjacent triangles. So we'll take 1 and 2. You can do 2 and 3, or 3 and 4, or 4 and 1, but not opposite triangles. Now in triangle 1 and triangle 2. Okay, triangle 1 and triangle 2. AS is equal to QB. AS is equal to QB. Why? Because the outer one is a rectangle, opposite sides are equal. So AD is equal to BC. So half of AD will be equal to half of BC. Half of AD is AS is equal to half of BC is BQ. So AS is equal to BQ. And then the outer one is a rectangle. So the corners are right angles. So 90 degrees. And then AP is equal to PB because P is the midpoint. P is the midpoint of AB. So AP is equal to PB. So in these two triangles, SAS rule, the triangle is a congruent because it's about this side, and this angle. SAS rule, the two triangles are congruent. CPCT, the hypotenuse, this one is equal to this one. But what are PS and PQ for the quadrilateral PQRS? They are the adjacent sides. PQ and PS are the adjacent sides of the quadrilateral of the parallelogram PQRS. We already proved PQRS is the parallelogram. Now PQ is equal to PS. Adjacent sides are equal. Therefore, it's a rhombus. Therefore, it's a rhombus. So ADC, see the triangle ADC, midpoint theorem, you get these two results. Then ABC, midpoint theorem, you get these two results. Comparing these results, you get PQ parallel to SR, PQ is equal to SR, parallel and equal. Therefore, it's a parallelogram. We're done with one part. Now, in these two triangles, in this triangle and in this triangle, AD is equal to BC. AD is equal to BC. Half of AD is equal to half BC. AS is equal to BQ. AS is equal to BQ. Then 90 degrees. 90 degrees. Then AP is equal to BP. Yeah, AP is equal to BP. So the triangles are congruent by SAS rule and CPCT. PS of this triangle is equal to PQ of this triangle. But PQ and PS, they are the adjacent sides of the parallelogram, PQ and S. So by definition, it's a rhombus. This one is similar to the example here. This one. It's similar to this one. So you just have to say E is the midpoint. This is parallel to this. Therefore, G is the midpoint. Now, G is the midpoint. This is parallel to this. So this is by converse of midpoint theorem. Therefore, F is the midpoint of BC. By converse of midpoint theorem. This is by converse. All the three lines are parallel. And it's given that E is the midpoint of AD. This is given. This is given. E is the midpoint of AD is given. We need to prove that F is the midpoint of BC. This is given. This is not given. This is to be proved. So in this triangle ADB, E is the midpoint of AD. EG is parallel to AB given. Therefore, G is the midpoint of BD. Now, in this triangle, G is the midpoint of BD, and this is parallel to this. Therefore, by converse of midpoint theorem, F is the midpoint of BC. See the statement. Actually, I wanted to do 8.1 at first and then 8.2, but you could see, no, I was not able to open the presentation. Did you notice that? I tried to open it, I don't know, put some error. It's a repair. So if I give that, if I had selected that, then it's difficult to come out of it. Or I may have to restart the laptop. Okay. So here, so it's given that E and F are the midpoints. E and F, ABCD, the outer one is a parallelogram. E and F are the midpoints of AB and CD. Now you need to show that DP is equal to PQ is equal to QB, which means the line segment, these two lines, what is BD? It's a diagonal. BD is a diagonal. The diagonal is trisected is what you have to prove. The diagonal BD is trisected. That means cut into three equal parts because of the lines AF and EC. See, it's like there is a parallelogram and it's diagonal BD. Okay. There's a parallelogram and it's diagonal BD. Now suddenly there comes a line AF. It cuts the diagonal BD. And suddenly there comes another line EC, which also cuts the diagonal BD. Now these two line segments AF and EC, they cut the diagonal into, I'm sorry, these two line segments AF and EC, you must prove, cut the line segment, cut the diagonal BD into three equal pieces. Who is there? There is a parallelogram ABCD with its diagonal DB. There comes a line segment AF. Now this F is the midpoint of DC. Okay. So you can see that AF cuts BD. There comes another line segment from here, from the midpoint, from E, which is the midpoint of AB. There comes another line segment like this. So you can see this EC also goes over the diagonal BD, cutting BD. So now these two line segments, what they do, they cut the diagonal BD, right? You need to prove that these two line segments cut the diagonal BD into 3 equal pieces. Show that the line segments AF and EC trisect the diagonal BD. Show that the line segments AF and EC, they trisect, they cut the diagonal BD into 3 equal pieces. Probably these want to be doctors in future. Okay. So, yeah. Now this is, you need to first prove that this quadrilateral is a parallelogram. You need to first prove that this quadrilateral is a parallelogram. How? AB is parallel to CD, correct? Is AB parallel to CD? AB parallel to CD? Yes, because ABCD is a parallelogram. Then is AE a part of AB? Yes, AE is a part of AB. And is CF a part of CD? Yes. So if AB is parallel to CD, a part of AB, which is AE, is definitely parallel to a part of CD, which is CF. So parallel. Now, AE is also equal to CF. Why is AE equal to CF? Because E is the midpoint, because AB is equal to CD. So half of AB will be equal to half of CD. What is half of AB? AE. Because E is the midpoint. And what's half of CD? CF. Because F is the midpoint of CD. F is the midpoint of CD. So half of CD is CF. AB is equal to CD. Opposite sides of parallelogram equal. Half of AB equal to half of CD. So half of AB is AE equal to half of CD is CF. So we proved that this is parallel to this and also equal. So it's a parallelogram. Now you proved this is a parallelogram, which means both the pairs of opposite sides are parallel. Both the pairs of opposite sides are parallel. Okay. Now take up this triangle. That is the triangle which should take, should include this midpoint. Okay, where is F? On the side DC. So the triangle you take up should include DC. Okay. And what you want to prove is you want to first prove that DP is equal to PQ and later prove that PQ is equal to QB. In order to show that A is equal to B is equal to C, you need to first show that A is equal to B, or you're trying to show that A is equal to B and B is equal to C. And so A is equal to B is equal to C. So in order to show that these three segments are equal, you're trying to show that DP is equal to PQ and PQ is equal to QB. So all the three are equal. Okay. So the triangle you're going to take up should include DP and PQ. That means it should have the side DQ. And it should also have the side DC because F is the midpoint. So obviously the triangle is DQC. Triangle is DQC. DQC because F is the midpoint of DC. So you want the side DC. And you are trying to prove that DP is equal to PQ. So you need this side DQ. So in this triangle, use the converse of midpoint theorem. F is the midpoint of CD given. FP is parallel to CQ because you proved it's a parallelogram. No, you proved this one is a parallelogram. So these two sides are parallel. So these are parts of these line segments. So they are parallel. FP is parallel to CQ. So by converse of midpoint theorem, P is the midpoint of DQ. P is the midpoint of DQ. By converse of midpoint theorem, P is the midpoint of DQ, which means DP is equal to PQ. Next, you have to take a triangle which has a side AB, because there we have this information, E is the midpoint of AB. And now you want to prove that PQ is equal to QB. So you have to take, meaning the triangle you take should include the side BP. Now completed. In triangle ABP. In triangle ABP. E is the midpoint of AB. And then it's parallel. Yeah, EQ is parallel to AP. Therefore, by converse of midpoint theorem, Q is the midpoint of PB. Q is the midpoint of PB. So that means PQ is equal to QP. So now comparing these two results, you will have all the three segments are equal. So here it's a triangle, a right triangle ABC. Right triangle ABC, right angle at C. That's why we put C here. Right angle at C. Right angle at C. So C here. You don't mark A, B, C. A, C, and B because C is the vertex containing the right angle. A line through the midpoint M of the hypotenuse AB. A line through the midpoint M. So this is the midpoint of the hypotenuse AB and parallel to BC. So, and parallel to BC, BC is here, parallel to BC, intersects AC. It meets AC at D. Show that D is the midpoint of AC. Everything is given. What? M is the midpoint of AB, given. And through M, MD is parallel to BC, given. So by converse of midpoint theorem, D is the midpoint of AC. D is the midpoint of AC. So D is the midpoint of AC by converse of midpoint theorem. Now, this is 90 degrees, right? These lines are parallel. So corresponding angles are equal. Parallel lines, transversal, corresponding angles are equal, 90, 90. So because this is 90, this is also 90. Because corresponding angles are equal. So MD, so that means MD is perpendicular to AC. MD is perpendicular to AC because it makes 90 degrees here. This is 90, so this is 90. Because corresponding angles are equal because lines are parallel. So if this is 90 degrees, it means MD is perpendicular to AC. MD is perpendicular to AC. Next, we have to show that CM is equal to MA. CM is equal to MA. So CM actually, in the figure, you don't have CM. So you have to join CM. Join CM. Later, you'll have to join. When needed, you'll have to join. So draw the figure and join CM. Or if you've already drawn the figure, join CM. You need to prove that CM is equal to MA. CM is equal to MA. Okay. So to prove that CM is equal to MA, you need to show that these two triangles are congruent. Because MA is of this triangle and CM is of this triangle. So show that these two triangles are congruent. This becomes a common side, right? And okay, this is the common side then. 90 degrees, 90 degrees. And then AD is equal to CD. CL. in these two triangles, in this triangle and in this triangle, this is the common side. And because this is 90 degrees, I marked it here, angle 2 is equal to angle 3 because we proved that 2 is 90 degrees. So 2 and 3, 90 degrees. And then AD is equal to CD. AD of this triangle is equal to CD of this triangle because we proved that D is the midpoint of AC. We proved that D is the midpoint of AC. So the two triangles are congruent and CPCT, we will have this result MC is equal to MA. Okay. Now we proved this one. CM is equal to MA. MC is equal to MA. We proved this. Okay, CM is equal to MA. We prove. Now we should prove that these are equal to half AB also. See, MA is equal to half AB, right? MA is equal to half of AB. Why? Why MA is equal to half AB? Because M is the midpoint of AB. M is the midpoint of AB. So yeah, MA is equal to half of AB because M is the midpoint and the two halves are MA and MB. So each of this will be equal to half of AB. MA is half AB and MB is also half AB because M is the midpoint. So this is true, no? MA is equal to half AB is true. And because MA is equal to CM, CM is also equal to half AB. So see here. So we have MA is equal to CM by CPCT, right? So MA is equal to half of AB. Why? M is the midpoint of AB. MA is equal to half AB because M is the midpoint of AB. So when you compare these results, MA is equal to CM and MA is equal to half AB. So MA is equal to CM is equal to half AB. It's like A is equal to B and A is also equal to C. So A is equal to B is equal to C. So this MA is equal to half AB. And also MA is equal to CM, we have proved CPCT. This one in the middle, no? This MA is equal to CM, CPCT. And MA is equal to half AB because M is the midpoint of AB. So this is equal to this CPCT. This is equal to this because midpoint is given. So that means all the three are equal. Give you some 15 minutes time to revise by yourself. Do you have the book in which you have the proofs? Yes or no? Don't have, is it? Nobody? Sunday, take your test notebook and no, not the textbook. The tuition classwork notebook in which you have the proofs we discussed now. Yeah, write down these questions, test questions. No, not based on this. I'll tell you. Please wait. Yeah. This is test 5, right? Harsha, kindly disable your mic. Yeah. Don't take the first one. Okay. I don't know this proof is out of your syllabus or no, now that it's deleted. Have you learned this in school? Prove that the sum of the four interior angles of a, yeah, we'll ignore it. It's not a difficult proof, but yeah, you can just ignore it now. Yeah, right now, copy the figures, copy this one. I want you to write down, this is one, this is question number 1. This is question number 2. This is question number 3. This is question number 4. And this is question number 5. Ignore these. Yeah. You just came? I don't notice you. You finished? Oh. Write the marks also alongside. So that figure is for 2 marks. Question number 1, 2 marks. Question number 2, 2 marks. 3 is also 2 marks. 4, 3 marks.